Howdy, in this video we're going to look at the normal distribution. Normal distribution is also referred as Gauss distribution. If you plot the distribution curve, you will see the curve is symmetric and it has a bell shape. In the question here, it asks for the production of iron rods. The diameter x has a mean of 2 inches and standard deviation of 0.008 inches. Assume the distribution is normal. Then what is the percentage of defects if we set the tolerance limit at 2 plus minus 0.02 inches? Let's look at the question graphically. What the question really asks is if we have the normal distribution with the mean of 2 inches, what is the probability of having the iron rod diameters fall into the interval of 2.02 and 1.98? The probability will just be simply the area under the curve enclosed by this interval. The formula to calculate the probability of x less and equal to a can be written down as phi. It's a function, a minus mu over sigma, where mu is the mean and the sigma is the standard deviation. Looking back at the graph, which is 2, in order to have the probability confined by this interval, what we can do is we calculate the probability that's less than 2.02, as shaded here, minus the probability less than 1.98. Using the probability on the left minus the probability on the right, we'll get the probability in this interval. So the probability of the iron rod diameter to be greater and equal to 1.98, but smaller and equal to 2.02 can be written down as the probability of x less and equal to 2.02 minus the probability of x less and equal to 1.89. Let's plug in the numbers. So this expression can be written down as phi. In the first case, a is 2.02, so 2.02 minus the mean, which is 2, divided by the standard deviation, which is 0.008, then minus phi. In the second case, a is equal to 1.98 minus 2 divided by 0.008. And this is equal to phi 0.02 over 0.008 minus phi minus 0.02 over 0.228 equals to phi 2.5 minus phi minus 2.5. Starting from here, we need to use the normal distribution table. These are the normal distribution tables. In the first case, the z number or the x number is 2.5, so it's 2.50, so we can just read it from the table. The value is 0.9938. In the second case, the z value or the x value is minus 2.5, so it's here. The corresponding value is 0.0062. So plug in these values into our previous expression. So the expression equals to 0.9938 minus 0.0062, which equals to 0.9876. This is the same as 98.76%. So what this probability tells us is we have 98.7% of the iron rods fall into the interval of the diameters 1.98 and 2.02. If the defect having dimensions outside this interval, then the defect probability is simply 1 minus 98.76% equals to 1.24%. In this video, we have encountered the concept of interval. In the next video, we'll introduce a new concept of interval called confidence interval.